there, STEM students! Welcome to another math-terrific video lesson of Senior High School Pre-Calculus with STEM Callisto Group 6. Together, let's discover and enjoy the wonders of math. Are you ready? Kindly get your pen and notebook and let's understand today's lesson in fun and easy way. Today's lesson is all about situational problems involving trigonometric identities. Ready? Let's get started. Trigonometric identities have many real-life applications in different fields. It is important since in calculus, we can replace either member with the other. In your previous lesson, you have built your understanding on determining equations, whether identity or conditional equation, and applied trigonometric identities to find other trigonometric values. This module will provide you with information and activities that will help you understand how to solve problems involving trigonometric identities. At the end of this video, we must be able to achieve the following objective: solve situational problems involving trigonometric identities. Introduction. Trigonometric identities are used to evaluate trigonometric functions, simplify trigonometric expressions, and verify other identities. Because of these identities, mathematicians were able to solve problems in the different fields, such as in calculus and all its application. These identities are used to solve situational problems, such as in the fields of architecture, in measuring roof angle, calculating heights of trees and buildings, and developing large infrastructures. Astronomy, in determining distance in space between planets and moon phases. Music theory, in calculating sound waves. Oceanography, in tidal change using trigonometric graph and depth of underwater objects. Gaming, in projectile and trajectory in games. Engineering, in calculating alternating electric current and determining the sizes and angles of mechanical parts using trigonometric relationship. And in physics, in calculating equilibrium, forces, and work. Discover. Trigonometric identities are of central importance in solving problems in calculus and different fields. These equations model real-life applications such as into events we might not immediately recognize. Studying the examples below and consider the guide questions to solve these problems involving trigonometric identities.
This four-step process in problem solving is used all over to aid students in problem solving, and these are 1. Understand, 2. Devise a plan, 3. Carry out the plan, and 4. Look back.
To understand more of our lesson, here are some examples of problems and how to solve them.
The first problem goes this way. Anton, a baseball player, hit the ball at an angle with an initial velocity of horizontal distance d traveled by the ball. The range is given by the horizontal distance r equals to sine theta cosine theta. At what angle theta does r maximum? Given r is equals to 1 over 16 with the initial velocity of the base of 0 raised to 2 sine theta cosine theta. Unknown theta where r is at maximum. Identify a trigonometric identity to be used to simplify the given r is equals to 1 over 16 with the initial velocity of the base of 0 raised to 2 sine theta cosine theta. Then we use the double angle formula to rewrite the given. Sine 2 theta is equals to 2 sine theta cosine theta. R is equals to 1 over 32, the initial velocity of the base of 0 raised to 2 sine theta cosine theta. Then we analyze and solve and divide both sides by 2. R is equals to 1 over 16 with the initial velocity of the base of 0 raised to 2 sine theta cosine theta over 2. Since the largest value for sine function is 1, occurring when theta is equals to 90 degrees. For maximum r, we must have 2 theta is equals to 90 degrees and theta is equals to 45 degrees. In conclusion, at an angle of 45 degrees, the range r is at maximum.
Problem number 2. Find the exact value of cosine 105 degrees with a given cosine 105 degrees and the unknown of exact value. Solution. To simplify, Identify a trigonometric identity to be used to simplify the given. Cosine with the identity of 60 degrees plus 45 degrees is equals to cosine 60 degrees cosine 45 degrees minus sine 60 degrees sine 45 degrees. Is the cosine sum identity. Cosine A plus B is equals to cosine A cosine B minus sine A sine B. Cosine 60 degrees plus 45 degrees is equals to 1/2 times the square root of 2 over 2 minus the square root of 3 over 2 times the square root of 2 over 2. Then, we analyze and solve. Cosine 60 degrees plus 45 degrees is equals to the square root of 2 minus the square root of 6 over 4. Conclusion. The exact value of cosine 105 degrees is the square root of 2 minus the square root of 6 over 4.
Problem 3. Given sin theta is equals to 3 over 5 and 7 over 2 less than theta less than 7, find sine 2 theta and cosine 2 theta. With the given of sin theta is equals to 3 over 5 where theta is quadrant 2, unknown sine 2 theta and cosine 2 theta. Simplify. Identify trigonometric identity to be used to simplify the given. Cosine theta is equals to negative square root of 1 minus sine raised to 2 theta is equals to negative square root of 1 minus 3 over 5 raised to 2 is equals to negative 4 over 5. Then we use the Pythagorean identity to determine cosine theta. Sine 2 theta is equals to 2 sine theta cosine theta. Then sine 2 theta will be equals to 2 times 3 over 5 times negative 4 over 5. Then it will be sine 2 theta is equals to negative 24 over 25. Conclusion. Sine 2 theta is equals to negative 24 over 25 and cosine 2 theta is equals to 7 over 25.
And for you to be guided, here's some additional information related to the topic. Always remember that in quadrant 1, all trigonometric functions are positive. In quadrant 2, only sine and cosecant functions are positive. For quadrant 3, only tangent and cotangent functions are positive. And for quadrant 4, only cosine and secant functions are positive.
And that ends our video lesson for today. I hope you had fun understanding our lesson and learned how to solve situational problems involving trigonometric identities. This has been Jade Andre Latoja,
Emmanuel Grata,
Krista Odecta.
Christian name Galis.
And Charles Guarda.
Thank you, everyone.